All right, we will be beginning lesson 4.2 into math for 5th grade. Interpret numerical expressions. I can compare numerical expressions which are written with one expression in terms of the other. Spark your learning. Michael and Sandra belong to a remote control club. They replace the batteries in their cars once a week. How does the number of batteries Michael and Sandra use in 3 weeks compared to the number of batteries they use in 1 week? Compare the number of batteries they use. Draw to show your thinking. So we're going to use this picture, and then for 1 week, how does the number of batteries Michael and Sandra use in 3 weeks compared to the number of batteries they use in 1 week? So we're going to use the picture, right? And which one has the 3? Sandra, right? And then Michael has 2, right? Okay, so Michael has 2 in a week, right? Sandra has 3 in a week. Okay, so for 3 weeks, he would have 2, right? Okay, and then she has 3 each week, right? She has 3 batteries in 3 weeks. This is your depiction of 1 week. And this is your depiction of 3 weeks. Okay. Okay, so basically what we said was we showed our picture for 1 week, how many batteries they used, right? And then we grouped our other part for the 3 weeks, right? Okay, so basically they used 3 times as many batteries that they did in 1 week. Okay, so in 3 weeks they used 3 times as many batteries as 1 week. Okay, so write a numerical expression to model the number of batteries they use in 1 week and in 3 weeks. So in 1 week, we would have to do what? Add, subtract, multiply, or divide. Just add, right? So the first week would be 2 plus 3, right? So 2 for Michael and 3 for Sandra. And then for 3 weeks, we put what? 5 times 3. Well, 3, right? 3 times because we had 3 weeks. And then we still have our same equation, right? That we originally started with. And then that goes in parentheses. And then the parentheses means what, guys? That when we went to solve it, that we would do that step first, right? Okay. Building understanding. The remote control club has 2 runways where airplanes take off. The size of the runways are shown on the map. How can you model the area of runway 1 using a numerical expression? Okay, so what would we do to find the area of map 1? Okay, so 16 times 9. Or with that, it could also be written as 9 times 16, right? You could go either way since it's multiplication. How can you model the area of runway 2 using a numerical expression? So 3 times 16, or we could do 16 times 3 because it can be either way, right? If you have multiplication. Describe the length of each runway. Okay, so basically, what can we say? Both of them are what? What's the length of both of them? Okay, so both lengths are 16 yards. Compare the width of the runway. Okay, so the width of this one is 3, and the width of that one is 9. So the width of runway, which one's bigger? Of runway 1 is how much? It is 3 times the width of runway 2. Compare the areas of the runways without evaluating them. Okay, so if you have the length the same and you have the width that is 3 times more, would the area also be 3 times more? Yeah. Okay, because you have 2 common factors, right? Okay, and so those kind of cancel each other out. So now the only factors you're comparing then are the width, right? Okay, so the width of runway 1 is, or not the width, sorry, the area. Is what we say? 3 times as much as is 3 times the area of runway 2. So compare the numerical expressions that model the area of each runway. Explain your reasoning. So we said the numerical expressions are 3 times each other because 9 is 3 times more than 3. Mr. Lu follows the directions shown when he flies his remote control plane. Okay, so over here we have to use the directions that they give us in the little manual, right? Add 15 milliliters of oil daily, add 5 milliliters of oil for each flight. Okay, so how can you model the amount of oil he needs for one flight of one airplane using a numerical expression? So each day he needs what? The 15, so 15. And then am I adding, subtracting, multiplying, or dividing? I'm adding, because then he did one flight, which caused him to add how much more? 5. How can you model the amount of oil he needs for one flight of 4 airplanes using a numerical expression? Okay, so, well, what does he need every day? 15 plus 5, okay? And then how many airplanes did he do? Plus 5 times 4. Times 4. Okay. Now, can we also put the parentheses first and then the times 4 at the end? Yeah. In this case, you could have done it either way, but we'll just identify how many he had first. Okay. How do your numerical expressions from parts A and B compare? So how are they comparing? Well, they both have 15 plus 5, so that kind of cancels each other out a little bit, right? So what is being done then? So letter B is what? Is 4 times more, right? Okay. So it's expression B is 4 times more than A because both have 15 plus 5, comma, but B is multiplied by 4. Check for understanding. Each month for 2 months, Kyle buys a pack of 8 replacement tires for his remote control car. At the end of each month, he has 1 tire left. Explain how the numerical expression for the number of tires Kyle uses in 2 months compares to the numerical expression for the number of tires he uses in 1 month. So we said after 1 month, our numerical expression would be 8 minus 1. Since he had 8 replacement tires and had 1 left after the month, then we wrote a new expression of 2 times parentheses 8 minus 1 because we now went 2 months down. So after we came up with that after 2 months, Kyle has twice as many tires left. Okay, so they want us to compare the numerical expressions 28 times 6 times 4 and 14 times 6. So what is common in both of those expressions?
They both have 6.
They both have the multiplication times 6, right? Okay, so we're going to compare the 28 and the 14. So what is the difference?
14 is 2 times. Yeah.
So 28 is 2 times larger than 14, right? So to explain our comparison, we put both expressions have times 6, but 28 is twice as much as 14. Okay, so the next one we have 3 times parentheses 8 plus 6 and 8 plus 6 for the other numerical expression. So what do both numerical expressions hold? 8 plus 6, right? Okay, so basically those kind of cancel each other out, right? So what is the difference between the two?
One has times 3.
The first one has times 3, right? So it's 3 times as much. So to explain our comparison, we put the first expression is 3 times as much as the other one because both have 8 plus 6. On your own, critique reasoning. James is making banners for his club's airplanes to pull. Each banner is 5 feet long and is attached by a 10-foot long rope. He models the total length of the banners and rope for 6 airplanes with the numerical expression 6 times 5 plus 10. He says the total length for 6 planes is 5 times as great as the total length needed for 1 plane. Correct his error. Okay, so we identified in order for him to correct it, James should have said 6 times as great for the total length. Okay, compare the numerical expressions. So this is just like what we did a little bit ago, right?
Yeah.
Okay, we're going to see what they have similar and then see what is different to compare them. So 33 plus 67 and 9 times 33 plus 67. So both share what in common? 33 plus 67. So basically the second expression is 9 times larger than the first. Okay, so for the next one we have 4 times 2001 minus 987. And for the second, we have 2101 minus 987. So what is our comparison? Okay, so both have 2101 minus 987. So the first one is 4 times more than the second one. Number 7, explain how 56 times 9 compares to 8 times 9. So we said that both expressions have times 9, but 56 is 7 times more than 8. Okay.